Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 21 of Python programming for data science. So let's get started. So in today's session we are going to start with a new visualization library which is Cbond. Last session we have seen about Matplotlib. So Cbond is a Python data visualization library which is based on Matplotlib only, and it provides a very high level interface for drawing attractive and informative statistical graphics. So we'll start with that. So first we will import the libraries. So first graph which we are going to see is a relational plot, and it can be used to plot a scatter plot or a line plot. And what this returns is, there is a concept called as facet grid, and it returns a facet grid which comprises of many subplots. It can be one subplot, it can be more than one subplot, and that represents your data. So here we have loaded our tips dataset, and you can see that we are trying to plot the relational plot between the total bill and tip variable. So by default it is a scatter plot. So here you can see we are specifying the color parameter, we are specifying the x and y variable. So this relational plot, which is a scatter plot, gives you a clear understanding about what is the relationship between two variables and how the data flows between the two variables. So it shows a slightly positive relationship. So if there is a high tip bill, high total bill, then there is a high tip as well. Similarly, you can specify some of the parameters like height and aspect. So height is actually the height of the graph in inches, and aspect ratio is the width of the graph. In what ratio of the height is the width? So width is actually 1.5%, 150% of the height, which is like this. Now there are some other parameters which you can pass in the relational plot. One is the hue. So this hue parameter, for example, if you want to visualize a categorical variable within a scatter plot, you can pass the hue parameter. So here you can see that for different days when the customer came into the restaurant, you can see the different colors of the bubbles, and you can specify the color palette as well. There are many color palettes available. Here we have used CMR map. So this is from the perspective of a scatter plot. Now there is one more benefit of using a relational plot, is that you can specify, or you can say it is an advantage in Cbond package. If I want to split this scatter plot by way of another categorical variable which is time, and the time is actually a column. So here if you see, it is dividing this single scatter plot into two plots based on the categorical variable time. So once this, what is the total bill and tip relationship with respect to time lunch and time dinner. So here you can see most of the people came for dinner in comparison to lunch. So this is column. Similarly, you can specify as row as well. So here I am specifying the row as well. So for example, if a person is smoker and time is lunch, what is the scatter plot you can see. So you can slice and dice your data from different visualization perspectives based on this parameter column and row in the Cbond package, and it becomes very easy to visualize your data based on the different categorical variables. And here you can see that smoker is equal to no and time is equal to lunch, and similarly time is equal to dinner. So if you see, if the person is not a smoker and the time is lunch, there is a strong positive linear relationship. Similarly, if a smoker if a person is not a smoker and time is dinner, there is a strong linear relationship compared to when the person is a smoker. So you can slice and dice your data in this way based on certain categorical variables, and you can derive meaningful insights out of it. Now let's say that I want to draw a line plot. So line plot is basically useful when you want to plot a time series data and you want to see the trend over a period of time. So here what we have done, there is a flights data set. I have pivoted that flight data set. So your year becomes your index, your month become your column name, and passenger is the count of the passengers for that particular combination. Now here I am trying to plot a relational plot between which is kind equal to line, palette is equal to autumn, and data is equal to flights fare. So it will plot the line plot for all these variables. So here we'll see. So this you can see that your x-axis is the index and your y-axis is the count of passengers, and your month is actually the hue parameter or the different columns. So here you can slice and dice your data. If it looks very cluttered, then we have another options which we'll see later. So line plot is very useful when you want to see the trend over a period of time. In addition to relational plot, there is a ScatterPlot as a built-in library which is available in Cbond package. So the ScatterPlot, we already know, it shows the relationship between two variables. We have the total bill and tip variable. We can see the relationship like this. There are some other parameters you can specify. We have seen hue parameter is equal to time, and you can specify the palette as well like this. So palette will make the graph more visually appealing, and hue is equal to time. So based on the time and time parameter, you can see different bubbles, and most of the people you can see came for dinner. You can also specify the style parameter. So style equal to time. So by default it takes the cross symbol and the oval symbol, circular symbol. So lunch is this blue circles and dinner is that orange cross. You can specify the markers manually as well. For example, if you want to specify lunch as square and dinner as circular, you can do like this. So here you can see the shape is changed. You can specify the markers equal to marker parameter. So you can pass it as a dictionary, or you can create a dictionary and pass it as a variable. Now there are some other parameters. For example, if I want to plot like this, so here what I'm trying to do is I want to visualize the size. So there is one parameter in the tips dataset which is size. Size says when a person is coming, what is the family size with which the person is coming. So if you see person with family size of 6 and 1 is very minimal. Most of the people came with family size of 2, 3, 4, 5, which you can see in the bubble chart also. So here what we are doing, this is size parameter. So if you have a categorical variable which is short of numerical in nature, you can specify that as the size parameter, and you can specify the size of the bubble. So for example, the first bubble will have a size from 20 and it will go up to maximum of 200. So it will divide the size between 20 to 200 into 6 parts. Legend equal to full means it will show all the legends or all the bubbles, and you can specify the palette as well. So this graph looks more visually appealing. You will get to see very clearly which family size visited more oftenly compared to other. Now same ways for line plot. So we have the flights dataset. This is the original dataset where we have year, month and passengers. Now let's say I filter out a specific year, only 1960, and I want to plot the passengers that flown on that particular year based on the month. So you can do like this, flights underscore data. Okay, like this you can plot. And here what I'm trying to do is, so this is for a single year over a period of time. You can see that in the month of June, July, August, September, there is a huge peak. And if I filter out a specific month for multiple years, you can specify X and Y parameters, and you can see that over a period of time the number of passengers flown increased drastically from 150 to 550 per month in the month of June. Now we'll talk about another graph which is histogram. We'll be using a inbuilt data set in the Cbond library, which is health expenditure. So histogram is used to graphically represent continuous data in form of frequency distribution, and here I am trying to do the histogram for the spending on the health. So if you see, this is the histogram. So this is based on various geography, which is country is a categorical variable, and the spending and life expectancy is a continuous variable. So here you can see that data is slightly positively skewed because the tail is towards the right hand side, and there are few outliers present in the data set. So histogram is also useful in identifying the outliers in your data set. Now let's say that I want to see the histogram based on the country as well. So you can specify the hue parameter as country and multiple equal to stack. So what it will do is it will convert the same histogram and it will highlight the different countries for a different distribution in the same histogram. So you can see what is the distribution of Germany, what is the distribution of France. Here you can see this purple color, which is USA, is actually causing this major outlier. So you can visualize it here. The visualization is not pretty much clear that which country is causing the outlier, but here you can clearly see that country like US is causing the outlier. So you can use this parameter hue is equal to country, which is a categorical variable, multiple equal to stack, so it will stack the chart one above the other, and element equal to step. Step means that one variable will be above each variable, so there will be no overlapping. You can also do like this. So you can see histogram, you can plot it very clearly, and you can do something called as KDE equal to true. So KDE equal to true is equal to more, we'll talk about what is kernel density estimate plot, but for now KDE is equal to is like a continuous probability density function of a of the data. It is more of a smooth graph which shows the trend of your data over a period of time. You can also, by default, it takes the count parameter for the histogram. So between different bins, what is the count of observations? You can also specify a parameter called as stat equal to percentage. So what this stat equal to percentage would mean is that it normalizes the data such that the bar height is equal to 100. So here you can see that the bar height will be equal to 100, and you will get to know that 25% between 0 to 1000 is the 25% of your data set. So this all the bar heights will be equal to 100. And then there is another plot which is called as kernel density estimate plot. So KDE plot actually visualizes the probability density function of a continuous variable. If you are not aware of probability density function, then please look up to my statistics playlist. There I have talked in detail about it. And the plotting can be done both for univariate and bivariate variable. So here if you go to see, you can see the probability distribution of the total bill variable in the tips data set. Color is equal to red and shade equal to true. Shade equal to true means it will fill this color, fill the color in the graph probability distribution. Similarly, you can specify like this. You can specify, so here X is equal to total bill. You can specify a vertical graph as well, like Y equal to total bill. So Y will be the probability distribution and X will be the density of that particular probability distribution. Now you can specify the different colors as well. This is based on bivariate KDE plot. So here you can see most of the distribution is concentrated between 10 to 20 total bill and 2 to 4 0 to 4 tip size. So you can see the darker the color is, the more concentration of the data there it is. So you can plot a KDE plot between two variables, which is bivariate analysis. It helps you to visualize your data based on two variables, what is the density of the data in terms of data points. And you can also specify the color bars as well. So you will come to know what is the density percentage of the data set for that particular combination of X and Y variable, which is tip and total bill. So here you can see that 2.6% of your data lies in this lighter yellow color between these two metrics, tip and total bill size. Now here also you can specify the KDE plot for multiple variables as well. So here we have iris dataset. You can see the KDE plot for multiple variables. So if you see, sepal width is normally distributed, and sepal length is also slightly normally distributed, but the petal length and petal width is not normally distributed. There is a lot of fluctuation in terms of the data. So like this, you can use KDE plot, line plot, ScatterPlot, histogram to visualize your data set in terms of your continuous variables, and you can gain meaningful insights from your different variables. There is also called as ECDF plot. So an ECDF plot shows the proportion of count of observations falling below each unique value in a data set. So here if you plot this graph, you can see that when the total bill is 20, close to 10 to 15% of your data points fall within that for the Saturday. So here hue is equal to day, which is a categorical variable. Stat is count. You can keep other stat metrics as well, like percentage, and palette is equal to rainbow R. So ECDF plot is also useful when you want to visually identify what percentage of your data point falls below a certain value. So these are very important graphs when we'll be talking about exploratory data analysis, to visualize your data, to understand your continuous variables. In next session, we'll be seeing some of the other graphs related to continuous and categorical variables, which will be helpful for your data analysis and the EDA part. So please subscribe, like and comment your channel, and stay tuned and stay connected. Thank you.